In today's video, we're going to see how we can perform dynamic routing using another protocol called OSPF. OSPF stands for Open Shortest Path First, and as usual, you can find the details of the routing protocol and how it works on internet. Right now, we're only going to talk about how we can activate and how we can advertise the only two tasks that we have to do whenever we are using a routing protocol to perform routing. Okay, so let's see how we can do that. We're using the same network diagram as previously, so let's go to enable mode and then let's check our routing table. And as you can see, only directly connected routes are there, no other route is present. So what we have to do is we have to go to the global configuration mode, and then we have to activate it. And to activate, we know we have to provide the router keyword and then protocol name OSPF, and then if you provide the question mark, we have to provide another option, that is the process ID. Okay, the range is between this, and this is the only difference, and a bit in network advertisement. So the basic process will remain the same. We have to activate the routing protocol and then we have to advertise. There could be subtle differences between how the protocol is activated and how the networks are advertised. Otherwise, the basic process is same. You have to activate the protocol and then you have to advertise the networks. Okay, so let's give an process ID. For example, I'm going to give let's say 92, because we're kind of using the 92 network in our previous video, so let's give that. And it could be anything between 1265535. Okay, you can do that. Okay, so let's advertise. And for advertisement, what we can do is we can provide the network keyword and then the network. Okay, 10.0. So let's provide a question mark here. Now the thing that's different here is, in RIP we only provided the network ID, but right now in OSPF we have to provide the network ID with a wildcard mask. Okay, as we have used subnet mask previously, and as you can see that the subnet mask when written is, for example, the class C is 255.255.255.0, so it represents the network portion of that current network ID. Okay, a wildcard mask is the opposite of a subnet mask, that it shows only the host bits. Okay, so subnet mask shows the network bits. Okay, and how it's written is that the subnet mask or the subnet portion that is being used for the network is turned on and host is turned off, while in wildcard mask the portion that is for the network is turned off, and the portion or the octet, you can say, because we have 4 octets in IPv4 address, the octet that contains the host portion is turned on and all the others are turned off. So if we were going to write the subnet mask, it would be like this. Okay, but right now we have to provide the wildcard mask. So wherever 255 is written, we will be writing 0.0.0, and where it had in subnet mask 0, here we will provide 255. Okay, so it's the complete opposite of a subnet mask. So that's a bit of a difference between RIP's advertisement and OSPF. And again, if we provide question mark, we also have to provide an area ID. Okay, so OSPF can have multiple areas, but in this video we are only going to cover a single area OSPF network. And as I already said, if you want to have detailed information on different areas and how areas works, you can find that on internet easily. Okay, right now we are only going to talk about the implementation. So area, and then we have to provide the ID. Okay, there you go. This one, like this. Okay, for example, I am going to provide area 1. So that's how you advertise. So for the second one, everything will remain the same, only the network ID will change. So there you go. So that's how you advertise an OSPF network. Okay, so right now, as you can see, there is no change. So let's go and activate the protocol on the other routers. Enable global. First, let's show a routing table, then global configuration mode, and then router OSPF, and then the process ID. Okay, so let's advertise network 192.168.20.0, 0.0.0.255, and area 1, for example. And then let's do that for, and as you can see, already a neighbor has been added. So let's do for 30, and let's do the same for 40. Okay, this is the neighbor being added. That means there has been an update and exchange in the routing tables. So already, so let's check the routing table here, and this is the route that has been exchanged from the router A, because it was also running OSPF, and this is the code for OSPF, that is O, so that's why it's showing an O here, and C for the directly connected. Let's check what change came in A. So yeah, 30 and 40 networks were exchanged from B. So let's go for C. Enable show IP arrow to get our routing table, then go to configuration mode, and then router OSPF, and the ID was 92, area net, sorry, not area, net 192.168.40.0, 0.0.0.255, and area 1. Okay, and the second is 50.0, and hopefully now all the networks would be added. So there isn't any change. Yeah, there you go. It took a second, and we have the 3 routes, 10, 20, and 30, that were missing, added by OSPF. And similarly, if we go B, we have the 2 routes that were missing, 10 and 50. And for A, again, we will have 3 routes added, that would be 30, 40, and 50. Okay, so as you can see, there isn't much difference between another routing protocol. First we used RIP, now we used OSPF, and hopefully in the next video we will be using EIGRP. So the basic process will remain the same, that we have to activate the routing protocol that we are going to use, and then we have to advertise our directly connected networks. The process can be a bit different, but the base solution or the base process would be same. The advertisement process and the activation process can be a bit different. Okay, so until next time, take care.